Solve equations using the distributive property. This set of Cornell notes actually comes based on lesson 5.3 from your book on pages 265 through 270. The essential question for this lesson asks, how do I use the distributive property to solve equations? Question number 1. What is the distributive property? The distributive property allows us to simplify an expression when order of operations cannot be followed. Let's consider example 1 from page 266 in your book. Solve equations using the distributive property. Each of the graphic novels in Chen's collection increased in value by $3.50 in the last few years. If each graphic novel has the same value, what was the original value of one graphic novel? Since we don't know the value of one graphic novel, we label that using the variable g. We know, according to the question, that in the last few years, the novel increased in value by $3.50. We also know by looking at the picture that in Chen's collection he has 10 graphic novels, so that means we're going to do this G plus $3.50 10 times, and the total amount the total amount of value for those 10 graphic novels is $75. In this problem, you can see that order of operations would tell us to do what is inside the parentheses first, G plus $3.50. But unfortunately, we don't know the value of G. That's what we're trying to find. So in order to solve this problem, we can use the distributive property to multiply each term on the inside of the parentheses by 10 and then solve the problem as a multi-step equation. In this problem, we need to use the distributive property to distribute the 10 on the outside to each of the pieces on the inside. Now, thinking back to the original question, again on page 266 in your book, we know that Chen had 10 graphic novels, which means the original value of those 10 novels was 10 times that number that we don't know right now. Plus, we're going to add to that the extra value that is there because the novels increased in value by $3.50. Since there were 10 of them and they all increased by the same amount, then we can multiply 10 times that $3.50 as well, and that's going to tell us how much the value of all novels together increased over that time period. What we know now is that the value of the 10 graphic novels, or 10G, plus the extra value, which we get from the increase, or 10 times $3.50, which makes $35, is now equal to the total value, which was $75. Remember that in order to simplify this equation, in order to solve it, we have to take the 10 from the outside of those parentheses right here, and we have to apply it to each of the terms on the inside. We know that we had 10 graphic novels, and we had increases of $3.50 on each of those 10 novels. So together we have 10G plus 35 equals 75. Now this is a two-step equation that we know how to solve by using inverse operations. And as we solve this, we'll do the same thing that we did before. So we're going to undo the adding of 35 to both sides by using the opposite operation, which is subtraction. So we're going to take away 35 from both sides. The 10G comes down to the next step. And 75 take away 35 is 40. In order to solve this the rest of the way, we need to divide both sides by what's in the multiplication problem, which was 10 times G. So G is equal to 40 divided by 10, or 4. So what we know is that each graphic novel was worth $4. In summary, to apply the distributive property, we need to multiply each term on the inside of the parentheses by the term on the outside of the parentheses. Now we'll do some practice on the back side. Go ahead and flip your paper over when you're ready. Question number 3. How can I solve an equation that has more than 2 steps? In order to correctly solve any equation, we need to be sure to do these 3 things. First, make sure that you combine any like terms. Second, use the distributive property to get rid of parentheses. And last, use inverse operations to solve for the variable. Now we'll do some practice problems together. Let's work through a problem together to apply that distributive property. The first thing that we do is we look for any like terms that we might be able to combine. In this problem, there are no like terms within the parentheses, and there's nothing that you can do outside of those parentheses to make this any simpler. So we simply have to apply that distributive property. What this means for this problem is the -4 on the outside of the parentheses, it's being multiplied, is going to actually get multiplied times each of these pieces on the inside of those parentheses. So as we do that, we're going to take the -4 and we're going to multiply it by p. Notice that there is a subtraction sign inside those parentheses, so we carry that over here. And then we're going to take that -4 and we're going to multiply it times the 212. So the -4 actually gets multiplied in 2 places because there are 2 terms inside those parentheses. Now, to simplify this, we do that multiplication. So we see -4 times p will make -4p minus -4 times 212. Get out your calculator. This is where it's helpful. And -4 times 212 is a -848. Now, mind you, this is all still equal to 44. Now, before we go on and do the actual equation solving, we need to clean this up a little bit. The -4p is going to stay where it is. But remember, subtraction is the same as adding the opposite. But the opposite this time of a -848 would be a positive 848. So when I change subtraction of a negative number, I actually end up adding it when it's positive. Now this is the equation that we're going to solve. So in order to do that, I'm going to do the opposite on both sides, and I'm going to do the opposite of adding 848, which would be in this case subtracting 848 from both sides. And again, get your calculators out to help you with the computation. Negative 4p comes down to the next step, and that's equal to a negative 804. Now we're going to go ahead and solve the last step. I'm going to move my paper up just a little bit here. There we go. And then we're ready to go ahead with our last step, which will be division. Because the negative 4 is multiplied by p, we are going to divide on both sides by that negative 4. And p is equal to, again, get your calculator out if you're not sure, okay? And we get 201. Now, I know that's positive because a negative divided by another negative will give me a positive answer. Let's try another question together. The next question that we'll try together is question number 4 on page 268. So again, I'm going to move my paper up a little bit here so we have plenty of room to work. This question reads, a family of 7 bought tickets to the circus. Each family member also bought a souvenir that cost $6. The total amount they spent was $147. How much did one ticket cost? One way to set up this problem is to note that we have family members, there are 7 of them, and each of them bought a ticket and a souvenir for $6. So the ticket plus the $6 is what one person spent, but there were 7 family members that went to the circus, and altogether they spent a total of $147. So what we're going to solve here is for t, which is the price of one ticket. To do that, we're going to apply our distributive property first. So we're going to multiply the 7 times the t plus the 7. Oops, let me change that color. Let's go back here. There we go. The 7 times the 6. And we know that the total spent was $147. Now, when we simplify that, we're going to be multiplying the 7 and the t together, and we're going to multiply the 7 times the 6, which is 42. Now, thinking about this equation that we have here, what we know is that 7 times t represents the cost of just the 7 tickets. The 42 represents the 7 souvenirs that the family bought at $6 each. So the 147 is the total combined cost of the tickets and the souvenirs. In order to solve this problem, we're going to take away first the cost of the souvenirs. So we're going to subtract the $42. Oops, you can't see that very well. Let me try that again. Let's try a different color. I'll go back to red. Let's take away the $42 that we spent, or that the family spent on those souvenirs. Once we take away those souvenir costs, we know that the family only spent $105 on the 7 tickets. In order to find out how much they spent on one ticket, we need to divide the $105 by 7 to see what the cost is for just one single ticket. And each ticket would be then $35. So you can see that that distributive property allows us to set up and solve problems that have multiple steps in them. Now I would like for you to go to your book and take a look at question number 7. I'm going to solve this problem and one or two others on the next page. You will do the solving part in your textbook. If you need additional paper, just go ahead and use notebook paper, or if you're in class, you can get a sheet of Cornell notes. In your book on page 269, we are going to solve together question number 7. First, I see parentheses, and there's nothing I can do inside those parentheses since x plus 5 are not like terms. Instead, I see that I have the distributive property because there's a number directly outside those parentheses that's being multiplied by the terms on the inside. So that's the step that we have to begin with. In this problem, we're going to multiply the negative 2 times the x and the negative 2 times the 5. Negative 2 times x is simply negative 2x. Negative 2 times 5 is negative 10. And use your calculator if you need additional support. I realize at this point that you probably have the boxes there, and you may be thinking, I don't know what to do with those boxes. It's okay at this point in your equation if you go ahead and just use the white space to the left of your problem. Don't worry about filling in the rest of those boxes for question number 7, but do show your work to the right side of that problem. The next step here would be to undo the adding a negative 10, and the opposite of adding a negative 10 would be subtracting a negative 10 from both sides. So the negative 2x will come down to the next stage. Positive 10 or adding 10x, let me start that sentence over. Adding a negative 10 and subtracting a negative 10 are opposite operations. 4 minus negative 10, when you type that into your calculator, turns into 4 plus positive 10 because subtracting a negative is the same as adding the opposite. So we end up with 14. Our last step then would be to undo negative 2 times x by dividing both sides by negative 2. And in this case, x equals negative 7. Let's try another question. This time, let's try number 12 at the bottom of page 269. This one is a word problem. It's set up very similarly to the question that we did about the family who bought tickets to the circus and also bought a souvenir. This time we have a family of 4, which means whatever we do, we're going to do it 4 times. A family buys 4 airline tickets online. The family buys travel insurance that costs $19 per ticket. The total cost is $752. Let X represent the price of one ticket. So we know that X is one ticket, plus we have an extra $19 in travel insurance for each of those tickets. In order to solve this problem, we have to apply the distributive property. We need to undo the multiplication of 4 times the total cost of a ticket, including the insurance, to only show the cost of the tickets and the cost of the extra travel insurance. Then we can solve the problem to determine the price of one ticket. So 4 is going to get multiplied by X, and 4 is going to get multiplied by 19. So again, this represents 4X, or 4 tickets, plus 4 times 19, which is going to represent the total cost of the extra insurance that was purchased for all of those tickets. Let me write that a little bit better. We know again that the total price is $752 for everything. So what we're going to do next is undo the extra cost, or the extra $76 that was spent on the travel insurance. So by subtracting $76, we can determine how much was simply spent on those 4 tickets. So 4x, or 4 tickets, had to be a total price of $676. Now, I need to divide the $676 by 4 to see what is the actual cost of 1 ticket. And 1 ticket would be cost $169. This concludes our lesson 5-3 on solving equations using the distributive property.